So I will introduce the topic, okay, that you see in this slide, okay, sustainable and smart goods distribution. So let me explain a little bit from our team, okay. I guess that you have already met Professor Robuste, who taught several sessions, okay, devoted to the innovative concepts of mobility. So I'm part of this team, okay, whose leader is Professor Robuste. But my topics of research are city logistics and transit network design. I'm also involved in the EIT Urban Mobility, just fostering innovative projects, okay, with the UPC community. So I'm going to talk to urban logistics, and we are going to base our presentations and the content of this presentation on the work done by our team, okay, of the PhD students and the involvement of this research hub staff, okay, the collaboration that we have with Volkswagen and Seat Research Club. So these are the topics that we are going to cover, okay, during this presentation. Okay, first of all, I will introduce the urban challenges and problems that all cities are facing today in terms of good distribution. Later on, we are going to fill you in the stakeholder relationships between stakeholders. We are going to propose or to analyze the innovative improving measures just to reduce the the carbon footprint on the system, as well as reducing the operating costs. Later on, we are going to fill you in the system modeling just to calculate or to estimate the operative costs and the impacts that these measures will achieve. And finally, we are going to introduce the business models, and we are going to conclude this presentation just highlighting the new technologies and powertrains. Okay, so these are appealing and promising technologies that will shape the the future of city logistics. So let's get started with the first point, the urban challenges. Okay, I guess that you are familiar with this situation. So this is the how the urban freight distribution has evolved in the last 100 years, in the last century. So we have the streets, plenty of vehicles. Okay, these vehicles in the 90s were different. Okay, were horses or human-powered vehicles. So the idea is, despite the innovations in terms of technology, okay, the city logistics is facing the same problems, okay, as do we we saw in the last century. So we need to integrate this city logistics or the freight transport with the rest of the services that the city is providing, because we know that right now almost the 80% of the European population is living in cities. So we have to combine and to allocate the urban space, the scarce urban space, to these different services in order to do our best, okay, and to provide efficient service. Nevertheless, in terms of city logistics or in terms of supply chain, we have to highlight that more than the 40% of the total cost of the supply chain is incurred in the last mile delivery. So when these parcels, when these goods are being distributed in the last mile in the urban space. So so the supply of goods or city logistics is a need for each city, and we have to conceptualize or think to wonder which is the most optimal allocation of space to the different services. Since city logistics is one of the main responsible of the congestion in traffic in all cities. In Barcelona, we have around the 20% of the total traffic is due to the distribution of goods. And we have here some figures in United States. Okay, this city logistics consumes around the 26% of the total fuel and produce the 41% of the greenhouse gas emissions. Okay? So I would like to mention here the different characteristics of freight transport or city logistics in comparison to the passenger transport. So when we move people, and if we plan, for instance, this evening, to move from home to cinema, probably I'm taking the decision alone based on the different options. But here in city logistics, we have multiplicity of agents interacting to take decisions: the carriers, the suppliers, the receivers, even the new marketplaces. And in terms of the physical movement of parcels, these carriers are concentrated into big companies, big firms, and these big firms are taking decisions on behalf of a multiple or a large amount of cargo. So only few companies are taking decisions on behalf of the whole spectrum of parcels to be distributed. Another point of interest is the wide opportunity cost margin. When we talk about people, okay, we analyze the value of time, and this value of time may range from 10 to, I don't know, 100 euros per person an hour, but in transportation of goods, okay, the opportunity cost margin is significantly higher. And in addition to that, we have to add all the complex and of urban environments that we discussed previously in terms of lack of loading and unloading parking spots, the vehicle size limitations, or the current tendency of the lack of drivers and high personal costs that Europe is living today. Okay, so when we mix all these things, all these concepts into we have to highlight the importance of the proper planning of city logistics in order to meet the requirements of the overall stakeholders. In addition to that, we have to realize the new tendency in terms of city logistics. So after pandemics, we have seen the skyrocket growth of e-commerce in all cities around the world, okay, as a viable option of distributing things, of distributing parcels from marketplaces to the final locations of potential customers. So this thing adds more complexity and pressure, okay, to this challenge that we have introduced before. So let's move to the second point to be covered during this presentation. And this point is the relationships and the potential impacts. So the principle and the key unit of transport is the vehicles times kilometer run. Okay, so we can calculate the energy consumption and emissions as the summation for all fleet typologies of the mileage run by this fleet times the energy consumption factor or the emission factor, okay, of this particular fleet. And the tendency was, okay, the vehicle manufacturers have improved the emission factors and the energy consumption factors. You could see on the right, okay, the different emission factors of CO2 and NOx depending on the European label. Okay, so in the second term, we did the homework, okay, and we addressed the problem. That's the first term, sorry. But in the second term, the mileage, we have seen that these vehicles per kilometer have been raised every year and every year. So it provides more complexity and more strength on the problem that we are facing today. Another point of interest that we have mentioned, no? Multiplicity of agents. Here, the spectrum of the number of stakeholders involved are more complex. Okay, so we have the producers and the shippers that they decide the frequencies and the shipment size. So they are taking important decisions in the supply chain. We have the receivers, okay, that they are against the distribution out of the commercial hours or commercial periods. They don't care about the minimal shipment size, and they require distribution very, very frequent. And finally, the carriers, okay, or the logistics service providers that try to accommodate all these requirements and try to fulfill the requirements at the minimum cost. However, we have to include as well non-direct, okay, stakeholders, city planners, traffic engineers that also add more complexity to the problem. But I would like to conceptualize, okay, this interaction in three different layers, okay? First of all, we have the economic layer, and this is the trade, okay, between a supplier and a receiver, okay, a trade. So in this economic layer, we define, as I said, the frequency of the shipments, the amount of shipments or the amount of parcels to be distributed, okay, so important things. However, this trade, this agreement between a supplier and retailer is translated into the physical layer as one truck or one van that is moving just to provide this parcel, this service, okay, to the final retailer. So is in this layer, in the physical layer, when we identify these different social and environmental impact in terms of CO2 emissions, NOx emissions, or in terms of congestion, okay? And we have the third layer, the legal layer. So these are the regulations, okay, imposed by the city councils and different authorities. And if we take a look to the agenda of the European Union, we have to realize that all the regulations have been focused on the physical layer, just okay, not addressing, okay, the important decisions taken in the economic layer. So in order to be efficient, we have to deploy and we have to prepare regulations that will effectively address, okay, the sources of the problem and will consider as well the actors and the stakeholders involved in the economic layer. Why? Because right now the supply chain is user-centric, customer-centric. So we live in the area of convenience, so that we have to consider this fact, okay, in order to deploy efficient actions. Well, let's move to the third point, the improving measures. So how can we improve the current system? How can we reduce the sustainable impact in terms of CO2 emissions, congestion episodes, etc. So let's take a look to this figure. I taking this figure from Olguín Beres, okay, Professor Olguín Beres from Brasileiro Polytechnic Institute. So he proposed this classification of measures depending on the orientation in terms of supply or demand. So at the top of this figure, we have all these measures more related to the supply side. So the construction of tunnels or parking slots dedicated to freight vehicles or freight fleets. And on the bottom, at the bottom we can see these innovative solutions that are closer to the demand side. So it means that we need collaboration among stakeholders in order to deploy this type of collaboration measures. We are going to focus, okay, from now on the consolidation of parcels in urban consolidation centers or other facilities, the time slotting of pickups, okay, or night distribution, and finally, in the access and vehicle-related restrictions or time access restrictions. So the question that I would like to highlight here is that if we analyze sums, okay, urban mobility plans, probably it's easy to understand that one measure just addressing the passenger situation or that's dedicated to passengers is justified, it's easy to understand. But when we try to translate the implementation of the same solution to the freight distribution, probably if we do that without understanding, okay, the different implications and relationships among stakeholders, probably the implementation of this measure doesn't bring the expected result, and we are not going to achieve a success. We have learned from the past in the implementation of reasonable measures okay, for passengers that have been translated into freight. One of them is the access control, okay? So Europe is leading the implementation of low emission zones in order to reduce the environmental impact. But in the past, there were several implementations and measures that were trying to create some kind of control, okay, neighbor control or city control, depending on the vehicle weight. And if we do that, probably this big van or this big truck, heavy truck that right now is banned and is being replaced by 3, 4, or 5 smaller vans or light trucks. So this switch of vehicle will bring unexpected results. And we have learned in these implementations in United Kingdom, when they do that or when they did that, they realized that all the metrics related to local pollutants or greenhouse gases were increased. So we worsened the current situation because of this substitution. This action has been also recently implemented in China, and they reached they achieved the same effect. Okay, an unexpected result of worsening, okay, these metrics or these KPIs due to this unexpected effect. The same happened with the pricing schemes. Okay, so in Europe, you know that Stockholm, London, they have the congestion charge or a toll system, and for passengers, this toll system is useful because passengers may have different alternatives, different transport alternatives. They can reach their destinations by train, by bus, by public transportation. But if we implement this toll system to the freight fleet, the alternative is to move the freight in non-peak hours or at night period. And it works well for big department stores when you have probably staff that will be responsible for receiving this kind of parcels. But when we expect that small local retailers will hire new personnel for night shifts, the tool that we have to implement in order to transfer, in order to switch, okay, from day deliveries to night deliveries would be higher than 200 euros in order to compensate to or the increment of night salaries in all the shops or small shops located in this neighborhood. So we have to be aware of this unexpected results, and we have to know the different relationships in order to deploy efficient and smart solutions. So let's move to the fourth topic that I would like to address today is how can we estimate the different costs or impacts in terms of cost, operating costs, and externalities. Well, just we can summarize a little bit. So the total cost will be the summation of the distance-based and temporal-based costs, okay, for the different vehicle typologies. And we have to include as well, okay, the depreciation of urban infrastructure in terms of urban hubs or even lockers if we are willing to distribute things with lockers, okay? And from the sustainability point of view, we can also analyze or estimate the externalities, okay, with the same fashion or with the same approach, okay, just considering, okay, the different impacts or proxies, okay, from cradle to grave times the distance run, okay? So this will be the monetary value of externalities per vehicle on kilometer run times this distance. But in this approach, we have to calculate or estimate the distance run or the time spent just traveling around the city, okay? So in order to do that, if we are able to do that, we are going to calculate the total cost incurred, in each solution, in the base case solution, so the conventional distribution, and we are going to compare this cost to the different new innovative solutions, scenario one and scenario two. In that case, scenario one is to visit a urban consolidation center and to distribute to the different shops, so to consolidate all the parcels in a consolidation center. And in scenario two is that the final leg from the consolidation center to the shop, we are going to use non-pollutant vehicles like cargo bikes, okay, or electric vans, okay. So we are going to compare this cost, and of course we have to take into account as well the incomes expected by the companies when they are switching from conventional distribution to the new scenarios or new proposals in terms of production. So finally, we have to consider and we have to estimate the potential benefits when or comparing the benefits in these scenarios, in the innovative scenarios, minus the benefits in the base case scenario. So in order to have all the stakeholders on board, okay, each stakeholders may experience a positive profitability. Okay, if not, there will be solutions that will be imposed by the city council, but they will force that this company will go bankrupt because of an unexpected structure of cost and incomes. Okay, so this is something that is very, very important when we propose different solutions in order to ensure that all stakeholders involved will experience a positive profitability. So the main or the key question here is how can we estimate in advance the cost that each company will incur when participating in this innovative solution? In order to do that, I guess that probably some of the colleagues from other universities will talk about that, but we have two potential approaches, okay? One of them is the combinatorial optimization model, so discrete models, discrete maps, in which we need to hide data sets in order to run, we have to generate graphs, etc., etc. However, in our university, we use for this strategical planning a continuous approximation technique. That is, we are going to work with expected values, okay, with expectations of variables, of functions, and we are going to provide compact formulas just to estimate the potential impact, okay, of one particular scenario or solution into the city. And probably one of the most or the well-known works in this research area is devoted or is proposed by the Carlos Daganzo. Okay, so he was able, okay, to provide this kind of compact formulations. And for instance, when you are willing to provide service, logistics service to an area of surface A, okay, and you are willing to visit N number of points or n customers within this area, it can be demonstrated that the total distance run is proportional, okay, with this coefficient to the root square of the area times the number of points. This is useful, or it works for Euclidean metrics. So the subindex here 2 means Euclidean metric, but you can also provide the same formula for Manhattan metric when you are following the Cartesian coordinates, okay? You are moving in a grid, just moving horizontally or vertically, and here the distance can be approximated by this formula. This works when you are visiting this area, but if you have to move from a depot, okay, to this area, so you have or you need different tours in order to visit all these areas. So it means that the fleet has a maximal capacity or vehicle capacity of Umax. We have to calculate, or we can calculate the total distance as the summation of the local distance, the same as before, proportional to the root square, and the line haul distance, that is the distance needed in order to reach the gravity center of the delivering area. And this is 2 times rho. Rho is the distance between the depot and this gravity center, times the number of points divided by the vehicle capacity. And let me explain here, the vehicle capacity is expressed in terms of the maximal number of customers that one vehicle is able to visit. So doing that, we can provide these compact estimations of the total distance and to infer the total logistic cost that one company is going to incur in each scenario. So if you need more details, of course, I can share with you, okay, the formulations for each particular innovative solution, okay, and using them, you can even estimate the total cost in this innovative solution, in this new transportation scheme. So let's move right now to analyze and to go in more depth to the business models behind different solutions that have been presented before. So right now I'm gonna focus on the idea behind the urban consolidation center. So the idea is to consolidate freight or parcels in different depots scattered in one region, in one city, and to distribute the parcels from these depots to the final shops, just using a more environmental friendly fleet. The second solution that I'm going to share right now is the night distribution. So the idea is to take advantage of the higher cruising speeds at night and the availability of parking slots in the city just to move quickly and to go or to distribute freight more efficiently, is just minimizing travel times. Okay, and finally, I'm gonna present, okay, some results of the potentialities of lockers. Okay, so here the logistics service provider, instead of visiting, I don't know, 100 customers scattered in one city, this logistics service provider will visit just 4 or 5 locations where these lockers will be deployed in order uh, to drop the different parcels and to make the supply chain more efficient. Okay, here you have some pictures, okay, of examples of these implementations. Okay, so in order to do that, we have to propose business models that will take into account the different relationships, okay, and power that the stakeholders have in each new collaboration scheme. This example was built for the micro hub or urban consolidation centers, okay? And this business model explains why in 2000, if you analyze the more than 200 implementations of urban consolidation center, you can explain why only 12 were in service. Okay, why? Because the business model is very, very strategic, and you have to propose a business model that will fit for the current situation that the stakeholders are going to address. So this is the current distribution on the top. And in alternative one, we propose that the urban consolidation center manager, so the company that runs the urban consolidation center, will charge a fair fee to the retailer. So if you don't know the different relationships, probably you will find that the retailer is not interested. Of course, they will be reluctant to pay a higher fare, okay, for the same service. And retailers are not going to take part in the new collaborative scheme. So they will opt for the conventional distribution, and they will be against, okay, the new system, or at least if this is a coercive measure, they will be against, okay, the city council because of the new distribution scheme. The second alternative would be, okay, as this solution is positive for the environment, the authority, the local authority, the city council will subsidize the operation of the urban consolidation center. However, for instance, in Spain, this is not sustainable, or city councils are against of this tendency because they had a lot of serious and legal problems when in the procurement side when they create the tenders and they open the tenders for the different logistics service providers. And finally, we have to understand the third alternative, the one that probably makes more sense. As the carrier is the agent or is the agent that will experience cost savings. Why? Because instead of visiting 20 customers, this carrier is going to consolidate the freight into the urban concession center. This carrier is going to experience cost savings, and the idea is to share part of this cost savings with the urban concession center provider or operator. So the idea is to charge carriers with a small fare that will be so low in order to make the system profitable for carriers and will be sufficiently high in order to compensate the cost that the urban concession center operator will incur. And this is the idea or the scheme that we implement here in Barcelona for different implementations. Okay. So right now I'm gonna identify the most important variables when deploying these innovative solutions that I've introduced before. So for the micro hub, urban staging areas, or the urban concession centers, probably the most important factors or variables would be the fare to be paid by the carrier to the UCC operator or the micro hub operator, the number of retailers served through the micro hub, and the facility cost. Okay, so one of the major deterrents of implementing this kind of things is the new facility cost, the facility cost of the urban concession center that the operators will incur. In the night distribution, one of the most important variables is to estimate the higher speeds, cruising speeds in the night period, and even the availability of parking slots, and as well the number of retailers served at night. And finally, for the lockers, the same as in the micro hub, number of customers served by locker service, the locker cost, and the area covered by each locker. So again, we have to calculate the expected economic impact for each stakeholder involved. And this is one of the tendency that we have realized for urban concession centers. For instance, for society, as we consider the society as a stakeholder, the implementation of urban concession centers is always, or in some cases, is profitable or is useful for the society. However, when we try to analyze the economic impact into the carrier or into the urban concession center manager, these variables or those profitabilities are negative. And that is why some of these stakeholders will raise their hand and they will say, I'm no longer taking part in this new innovative solution. For instance, here in these diagrams, you have in the x-axis, you have this fraction of parcels routed through the micro hub. It ranges between 0. It means that all parcels will be distributed with the conventional service, and 1, that means that all parcels will be distributed through the urban constellation center. However, you can have intermediate points like the one here depicted in red, in which more or less half of the parcels will be routed through the urban constellation center, and the biggest parcels probably that don't fit with the electric cargo bike, they are too big, and they will be distributed by van without traveling through the urban concession center. Okay, so the x-axis is the fraction of parcels, and the vertical axis is the density of customers requesting logistics services. So number of points to be visited by per square kilometer. And here we can realize that the same point in all three figures for society, as you can see, it means that the profitability rate is something between 0 and 100 euros per day. So it's positive. So it means that as a society, we have to foster this implementation. But for carriers, the same point, okay, is located in the negative domain of the profitability. It means that carriers are not going to experience a positive impact. So we need to change something in order to foster the participation of all of them. And it can be seen here if we bring or we create this multi-actor cost-benefit analysis, okay? The idea is to summarize the expected impacts, okay? In rows, we have the different effects in terms of, for instance, externalities, assets, operation, and in columns, we have the different stakeholders involved. And take a look here. This is an implementation, an analysis for one particular urban conservation center in Barcelona. Even if the project, the net present value of the project in the top, okay, you can see here is around 800,000 euros, it's positive, we can see that carriers will experience cost savings around 5 millions of euros, but urban concession center operator is going to experience a minus 3 millions of benefits. So it means that they will incur in an operating cost, and someone has to balance this cost in order to foster their participation. So the idea is to create this financial compensation on incentives, economic incentive, in order to share part of these cost savings or benefits experienced by carriers into the urban consolidation cost in order to balance the profitability for all stakeholders involved. Okay? And taking into account or taking a look to this table, we can understand why, okay, several implementations of urban consolidation centers made sense from the social perspective, but at the end, after 1 year of operation, the urban concession center operator went bankrupt and the service is no longer available. Well, I'm going to skip this. So just replicating the same approach, we can analyze the potentialities in terms of cost reduction of the different solutions that we have shared with you. So here we have the micro hub and the urban conservation centers. We have this scenario one in which we are going to visit all the points with the same fleet that we use from the supplier to the urban consolidation center. And if we take a look here, this fraction in yellow means that we are going to increase the operating cost with this innovative solution. It means that the service is not profitable for the carrier. In a scenario two, we see some domain in green. It means that the reduction of cost is around 10%. So we are going to reduce the cost from 1 to 0.9. So it means the 10% of cost reduction for this domain, but we have still a wide domain in which the cost is higher in this innovative solution. And finally, if we distribute the parcels from the urban consolidation centers using e-cargo bikes and with part-time workers, we can see that the green area is wider right now, and probably the implementation of urban consolidation centers is more justified. On average, we can have or we can see that in most of the implementations of urban consolidation centers, we can reach around 10-15% of operation cost reduction. If we repeat the same analysis for the night distribution, okay, just comparing the current scenario, okay, in the day distribution to the night distribution using the same fleet, we can see that the green and even the blue area is higher. So it means that in the 50% of the implementations, we may expect cost reduction. However, here we identify a controversial point. Here, if we increase the fleet size and we move from 9 cubic meters to 25 cubic meters, so a bigger truck, we can even reduce the cost up to 40 or 35%. So we can provide this estimation that the operation cost reduction in European cities using night distribution is around 30%, and this value is very, very close to the cost savings reported in different night shift programs conducted in Manhattan and in other cities, in other Brazilian cities. Okay. And finally, lockers. Okay. Here we replicate the same analysis and we are going to visit or to distribute parcels to B2C, to the final customers, using a bigger truck. And doing this, we can realize that the cost saving is more important here, and we can reach up to 40% of cost reduction. However, here we have to address these weaknesses. First of all, it will be accepted for the final users to move to the closer lockers in order to pick your belongings or your parcel up. Another thing to be aware, is there enough public space for deploying individual lockers for each logistics service providers? So probably we will have six logistics service providers in European cities. So we have to deploy dedicated lockers for each supplier, for each carrier, or carriers may share, okay, these lockers. And probably one of the most important question, who is going to estimate or even incur the cost of the locker maintenance? It's reported that lockers are vandalized, okay, they receive or that they have to be each month visited in order to provide the maintenance programs, and we have to take into account of these programs in order to calculate the corresponding cost, depreciation cost. Let me check the time. I'm just finishing. And finally, we are going to conclude this presentation just presenting the innovative or the most appealing technologies, okay, for logistics. So in the last 10 years, probably, we have seen the inclusion of and the deployment of new modular and zero emission and autonomous vehicles. So from the traditional electric cargo bike or human assisted cargo bike to new conceptualizations of technologies. The idea is, how can we introduce, are these technologies efficient for improving the city logistics? Well, probably the justification of these technologies, apart from the safety issues, is because we can reduce significantly the cost, the operating cost per vehicle kilometer and per vehicle hour provided. Okay, so here you have the cost per kilometers that have been reduced up to 0.054 in the new conceptualizations of vehicles. And if we take into account the cost per vehicle an hour, we can avoid the salary, okay, and the shift of the driving personnel, and the operating cost is almost 3 euros per hour of service. Okay. However, so generally speaking, transport costs can be reduced around 50% or by around 50% because of these autonomous vehicles. These are more or less feasible for passenger transport, but for me, the most important question is not how these vehicles can move in a urban environment. They have been demonstrated that they can move, okay? The technology is ready for that. However, the question is how people will pick the parcels up from these vehicles. So how can we interact, okay, at the destinations with these robots, okay? So the picture on the left, okay, when these vehicles are moving in the cities, for me, it's not controversial. For me, what is more important is how these vehicles will deliver, okay, the parcels to the final customers. So we have been in collaboration with Carnet and Volkswagen Group in order to test different solutions. Okay, here we propose a new collaborative scheme with technology in which the service will be provided in a two-echelon fashion. So first of all, there will be a vehicle that will depart from a distribution center out of the city and will access the city. They will drop all the parcels in the micro hub, and from this micro hub, different autonomous vehicles, small autonomous vehicles or autonomous delivery robots will visit the different points and will drop parcels that they requested. It's something like that. This vehicle has been tested, okay, in Germany, in Spain, and in Portugal, and we have different performance data sets in order to see the cruising speeds and the performance of this vehicle in urban areas. Well, we did and we carried out, okay, different sensitivity analysis. Here we use a data set provided by the OECD, okay, with more than 200 cities with different characteristics in terms of the urban logistics, average number of deliveries per day, cruising speeds, incomes, etc. And we did the following analysis and we reached the following results. Okay, so on the figure on the left, you have the histogram of the cost ratio of the total cost of the ADR. Okay, so it is the innovative scheme divided by the total cost in the business as usual scenario. Okay, so if this ratio is higher than 1, it means that the new technology is more expensive than the previous technology when distributing things. You can see here that the histogram is on the left of 1, so it means that we can achieve around or on average a 24% of cost reduction in a small and medium European cities. If you are, this paper has been published, so if you need more information, I can share with you, but it's something positive to understand this and to pave the way for the introduction of these vehicles in terms of cost reduction. However, we have another perspective, the sustainability. So here we perform a life cycle cost analysis. So as we prototype and build this kind of vehicles, we know the different amount of materials needed in order to build these vehicles, and we summarize the following information. Here in the picture on the left, we compare the grams of CO2 equivalent needed per delivery, uh, comparing the conventional vehicles used in the business as usual, that is internal combustion engine vans, the left, the orange, with a green global warming potential of 113 grams of CO2, with electric vehicles used in the business as usual scenario, the second column, in which the global warming potential has been reduced to 46, and we compare to the most reasonable scenario of implementing ADRs. ADRs stands for autonomous delivery robots, so is the situation for us more reasonable, in which the global warming potential is 83. So taking into account this, of course, if we compare autonomous delivery robots with conventional internal combustion engine, there is a positive effect. However, if we compare to the traditional electric vans, okay, the global warming potential of autonomous delivery robots is the double of one electric van. Okay, so we have to be very sensitive to this point and to be aware of this effect. However, if in the second scenario for ADRs, if we reduce the lifespan of the vehicle, of the autonomous delivery robot, just to 20,000 kilometers, the global warming potential is increased. So we constrain the mileage of these vehicles so that the global warming potential per delivery is double. And we can repeat the same approach, okay, for different scenarios in which these autonomous delivery robots will be deployed. And another thing to be aware is that this life cycle cost analysis depends on the electricity mix scenarios that we consider. And here we can see that for Germany, probably the electricity mix is not as based on renewable energy in Spain, and is 344 grams of CO2 equivalent per kilowatt hour provided, okay, generated. And in Spain, this figure is reduced to 171 grams of CO2 equivalent per kilowatt hour generated because of the renewable energy in Spain. So the analysis is country specific or site specific, and we have to take into account the electricity mix. In Spain, we can generate or we can summarize that the CO2 reduction or the global warming potential is reduced by 27%. And finally, we can also consider innovative solutions like the one presented here. This solution has been published 2 months ago, and the idea is to operate the autonomous delivery robot independently, just moving the bodies, the containers where the parcels are located, differently from the platforms that provide powertrain, okay, and movement. So if these autonomous delivery robots are loaded into a bigger vehicle, autonomous heavy vehicle, we can deploy ADRs in different neighborhoods of the city. In each neighborhood, we can operate, we can follow these bands. And finally, as we have autonomous heavy vehicles and autonomous delivery robots, the combination of this can bring important and promising implementations like the one that you can see here in terms of cost. Okay, the upper curve or straight line represents the business as usual, and the one here, in the bottom, okay, with circles, is the one representing the new scheme. You can see that on average we can achieve from 24 to 40% in terms of cost reduction. Okay, so we can reduce the operation cost by 40% in the European system. So these concepts, of course, are futuristic. The legal issues are not prepared. Okay, the legal regulations are not prepared to deploy these kind of things, but the service is promising in terms of operation cost. And the future would be something that will integrate all these services and measures that we have been discussed. And well, we are in contact with different editors of journals. And one concept that is leading in the agendas and or the topics covered by the journals is the freight as a service. Probably you are familiar with the concept of mobility as a service for passengers. And right now we are exploring the freight as a service. So the combination of all different innovative measures with a new collaborative schemes between stakeholders in order to deploy customer-centric solutions, but at the proper price or at the proper fare, in order to penalize those solutions that probably will go against the sustainability and to foster or to create some kind of incentive for those solutions that will be more environmentally friendly and will help, okay, us in order to mitigate the climate change impact. Okay, so that's all from my side here. I summarize, okay, the main conclusions. Probably I'm running out of time. So this is just a summary of the questions that we have reduced. But for me, the most important question here is we have to be aware of the different dimensions, okay, of the city logistics, the economic side, the physical side, and legal side, in order to understand the problem and to predict the potential response of stakeholders when you are proposing a new collaborative solution. That's all from my side. Thank you for your attention. And if you have any question, please email me at this miquel.estrada@upc.edu. Thank you for your time.